Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is talking about EVAP. So EVAP systems diagnosis. So we're going to go through kind of what all is in the EVAP system, how the EVAP system works, and we're going to talk about a little case study, I guess, on a vehicle that has some kind of unique components. I guess it's not entirely unique to just that vehicle, but it is some other things that you might not necessarily think of if you haven't had to deal with it before. So we'll talk through a few of those things, plus, of course, on tool. So first thing we're going to talk about is the different EVAP components, and these are the ones that pretty much any vehicle with an EVAP system is going to have. So we're going to have the purge solenoid, we're going to have the vent valve, we're going to have the canister, we're going to have the fuel tank pressure sensor, we're going to have pumps and other associated modules depending on the vehicle. So it could be NVLD, which is natural vacuum leak detection, eSIM, DMTL for BMW, and so on. So some manufacturers do that, some manufacturers don't. Some manufacturers have some other components that we're going to talk about in a little bit, but these are the ones that basically any EVAP system is going to have. Now let's do a little refresher on how it operates. So we got a little animation here on how the EVAP system works. So we have our purge solenoid up here, we have our vent valve down here, and we have our fuel tank pressure sensor here. We got our fuel tank, we got our fuel gauge, we got our engine, we got our PCM, and we got our canister right here to hold all of our vapors. So how does this work? Under default, the purge solenoid, which is going to be the front door to the engine, is going to be closed. And the back door, which is the vent valve, that's going to be open because we have to allow fresh air to be able to escape the tank when we're filling the tank, as the fuel will displace the air that's in there. So we'll put some fuel in there. As it fills up, there will be vapors generated. Once it is full, the vapors need somewhere to go. So they go into the tank, or they go into the canister, displacing the fresh air that's in there. All right, so now that it's full, we're going to start the engine. We're going to let it get up to temperature where it needs to be. And then we're going to open up the purge valve, which will allow the vacuum of the engine to pull in outside air to displace the vapors, to pull them in and get burned, reburned. Right. Once it's in that state, and once the tank has been cleared out or the canister has been cleared out, we then close the vent valve, or the PCM does anyway. Closes that vent valve, and now allows that to be open to the vacuum of the engine, and it'll pull a vacuum on the system. As you can see right here, the fuel tank pressure sensor. It's going to pull a vacuum. Once it's in vacuum, it's going to close the purge valve, and now we are in a vacuum state within the system. The computer is then going to start a timer, however long that needs to be, and tell whether or not that vacuum decays. If it does decay, then we know we probably have a leak. Depends on how fast it decays. If it decays very slowly, we have a very small leak. Might not be a large enough leak to be concerned about to set a code. However, if it decays quickly, then we know we have a fairly large leak in there. And the computers are calibrated to know, if it's over a 20 thousandths leak, it's a small leak. If it's over a 40 thousandths leak, it's a gross leak. Over 10,000 is a very small leak. It also knows what the fuel cap, the flow rate would be if the fuel cap was off, right? So that's how we can get gas cap codes. But size does definitely matter when it comes to diagnosing the size of the leak. So if, depending on the year of the car, like pre-2000s, about 40 thousandths is where it's going to set a code. Post 2000s, roughly, it's going to be a 20 thousandths leak. And most modern vehicles are down to even 10 thousandths or less for a spec for it to for a leak. So most systems are going to leak at least a little bit, but that's the spec. So let's look at a slightly different system. So this one's actually off a Jeep Grand Wagoneer with the 3-liter turbocharged engine that it has. And I picked that vehicle because, one, it has some unique features in it that you wouldn't normally see, at least on a naturally aspirated vehicle. And the other thing is they have really nice pictures from the OEM. And you are hard pressed to find some really nice, like, colored pictures that depict exactly how this system operates from most manufacturers. I don't usually say wonderful things about Chrysler, but I will say they do have excellent graphics and diagrams, so it makes life a little easier as a teacher, right? So we have our fuel tank down here. There's numerous check valves in there. We got pressure sensor there. It goes in the canister. The eSIM unit's on the side of the canister. We'll talk more about that in a little bit. Got a filter to the outside. Fuel vapor goes in the purge solenoid. We also have an OBD vent valve, which is going to allow it to vent when it's in certain conditions. But the big deal is going to be these check valves, and it's going to be, well, I have a turbo here. So on pretty much anything with a turbocharger that has an EVAP system, it is going to need some sort of a check valve. Because when I'm under boost and I'm pushing boost in here, that's going to push boost back this way as well into the solenoid, so I won't be able to purge because I need vacuum to purge. However, on the other side of the turbo, the inlet side of the turbo, it will be pulling a vacuum in order to generate that boost. So in the air box, there's what they call an ejector tee. So it's going to tee into the line. And depending on the situation in the engine, either it's under boost or under vacuum. If it's under vacuum, it's going to just go the normal way and into the intake. It's going to suck those vapors in. If it's under boost, it's going to have a check valve in there, and it's going to move the passageway down to here, and it's going to purge through the air box. So it's going to basically take it in under vacuum here and then be reburned that way. And then, of course, wherever the boost is going to have a check valve there. And there's check valves in here. There's numerous check valves in the system, so we don't have boost going where it's not supposed to go. And the vacuum can do its job when it comes to the EVAP system. So I know Honda's got something kind of similar as well. On their turbocharged vehicles. So really, it's a boost or no boost type situation as to how that all works. So just kind of interesting and unique. There's that check valve there, and then this is the purge solenoid, of course. So the check valve's in here, and it moves it depending on which way it needs to go. So vacuum port out, vacuum port to intake, purge port inlet from canister there. So how it's going to flow, if we want to take a look. From the canister through the purge solenoid into the intake manifold under naturally aspirated or vacuum state, right? When a non-boost state. Notice how the check valve is closed in that case. And this check valve is open. Down here is going to be under boost. So it goes through here, goes in here. It's also going to push on this ejector tee. It's going to tee it off so that the check valve opens. And from the canister through the purge solenoid down into the air box and then back into the engine like we showed earlier. The check valve in the air box is going to look like this. So the boost air comes in here and it's going to open it up, make a passageway for the purge air, and then it goes out to the air box. Also have the eSIM unit, which is the evaporative system integrity monitor. So this has two different weights. One measures vacuum, one measures pressure. And then it also has a micro switch in there and a diaphragm. So depending on the situation in the vehicle, this vacuum switch can flip the switch, or this heavier one is for pressure. So there's a really good description of it actually in the guided component test that we're going to look into in a few minutes. So I'll read through that to give you a better description of kind of what all goes on inside. Just know this measures vacuum and this measures the pressure. Canister. In this case, it's kind of a unique looking canister, I'd say. I mean, usually they're kind of just a box, but in this case, it's got a couple cylinders. It almost looks like there's that eSIM unit there, and then there is the filter that is on the outlet side of that vent as well. Fuel tank pressure sensor is also a bit unique in this situation. They mounted it kind of high up near where the filler neck is instead of on top of the fuel tank. Seems like it's a little easier to get to in this way, which is not a bad thing. They said they did it because possibly you might get water intrusion if you decide to ford a creek or something like that. To me, in my opinion, if it's a starts at $100,000 vehicle for the base model, I'm probably not going to be taking that off road. Maybe you would, but I don't know. Maybe that's just me. Maybe I wouldn't be fording rivers with my $100,000 SUV, but you do you. That's okay. And that's why they designed it that way, just in case that happened, I guess. Then we have a vent blocker valve in this system as well, so this kind of works to separate the canister side from the fuel tank side, so it can tell kind of where the leak may be if there is a leak in the system. It's able to cordon off one side or the other with that. So that I guess could be helpful in diagnostic purposes. And that brings us to EVAP codes. So EVAP codes, you need to pay attention to what the code says. I had an experience one time where someone called me up and they said, "Hey, I've been fighting this EVAP problem for a month or whatever. Anything you could come take a look and help me out?" So, okay. So I took a look, I scanned the vehicle, and the first thing that came up was a purge control electrical problem code. He's like, "Yeah, it's the code that keeps coming back." And I said, "Well, that's an electrical problem. That is not a leak. So maybe you had a leak, but most likely you did not have a leak if that was the only code that was in there. You've been chasing your tail on a leak when really you should have been checking the purge solenoid in that case." We tested the solenoid, it tested low. So replaced the purge solenoid and magically fixed the problem. But that is a word to the wise to always make sure you check, is it an electrical code, high input, low input, whatever, or is it an actual leak where it has small leak, very small leak, gas cap, etc. So you always want to make sure you're checking into that and just read the description. If for some reason you don't have the description on your scan tool, you can always go into service information and double check there as well. All right, accurate service information is what we want. So make sure we can test it properly. Now, if it is a leak, you're going to want one of these. Not necessarily this one, but any sort of smoke generating device, right? I say any machine's a smoke machine if you operate it wrong enough, but this one's actually designed to be a smoke machine and inject smoke into the EVAP system, amongst other things. This is the newest model, just came out. EELD 700A is a Snap-on one. Of course, there's tons of other ones out there in the ecosystem. It's got a couple unique features in there, like the orifice leak size backlit. I can do air only instead of smoke, in case you just wanted to find a leak without putting smoke in there. A couple other things. Talk to your Snap-on rep if you want more information on that, because I'm not terribly spooled up on that. It's a smoke machine. And if you are going to smoke the EVAP system, you're going to want to, many vehicles, not all vehicles, but many vehicles will have the little cap under the hood, the EVAP service port. Do note, if you are going to put smoke in there, you do need to take the Schrader valve out, and it's a righty-loosey, lefty-tighty situation, so it is a reverse thread. So make sure that you are aware of that, and then you would put the smoke in that way. If you don't have a service port, I say easiest thing's probably just find the purge control solenoid and plumb it in there on the hose if you can. Just find a nice place with a clamp or something that you can plumb it in and make sure you're going on the right part of the system. Put the smoke in. Where's the smoke come out? Easy enough to find the leak. I'll tell you, when I worked at the dealership, for some reason they really didn't feel the need for a smoke machine or an EVAP tester or anything like that. And if you know Subarus, and I live in New England, so Subarus in New England and Salt on the Road, and a lot of their EVAP components, at least back when I was working there, were made of metal tubing that goes through the metal frame, subframe, what have you. So invariably they would rust. I don't know if you know around 2000s era filler neck covers on a Subaru, right? There are just these plastic covers that would cover the filler neck, and invariably mud and dirt and stuff would get in there and just rot out the bottom of the filler neck. We placed tons and tons of filler necks on those, and that would also cause an EVAP leak, perhaps. Um, if it gets really, really bad, then you can't put fuel in the car and it just goes around the ground. But luckily, usually it didn't get to that point before it threw a code. But anyway, you might need to smoke in the tank as well. Here is a leaking vent valve, so that needs to be taken care of before you do anything else, because one of the first things you need to do on the EVAP system when you're going to put smoke in the system is you need to go in your scan tool, go to the bidirectional controls, and close the vent valve so it doesn't leak out the back, right? Because remember, the default state on a vent valve is open. So we want to make sure we close that. So in this case, this particular one was leaking even when it was closed. So that it needs to be addressed first. And then once that's addressed, you should be able to hopefully find the leak. Or maybe that was the leak. Possible. Here's another example of a leak. This is on a fuel sending unit that they replaced at like a high school. And they cross-threaded it by accident. They didn't realize it. And they're like, oh, now we got an EVAP leak. Where's the EVAP leak coming from? And sure enough, they can see it coming out of the top of the sending unit. Here's another one. I mean, this hose kind of looks like garbage to begin with at first blush, but you can see where it's definitely spewing out of that crack right there. All dry rotted and everything. So that could definitely cause a leak and a code. So that's leak testing. Smoke in, where's it come out? Electrical testing can be much greater simplified if you have a snap-on tool with guided component tests in there. It's going to tell you all about how the components work. It's going to tell you about where they are located, how to test them, where they are. I already said that, but how to test, where to test, and how to hook it up. And then it does the rest of the work for you. It sets up the meter and everything for you. So in this case, this is talking about the purge solenoid on a 2022 Camry, 12 volts in ground. It's going to tell you all about it. I don't need to kind of read through that, but that's just one of the examples, and we're going to see some more examples right now on a couple different vehicles. So first one I want to pull up is that Grand Wagoneer, and that has some guided component tests in there under the EVAP system. So we see we have the eSIM unit, fuel tank isolation valve, fuel tank pressure sensor, OBD vent valve, and the purge solenoid. So let's go to the eSIM. And like I said, it's got a pretty good description. So the eSIM, or Evaporative System Integrity Monitor, is very similar to the MVLD, although it does not require a solenoid. The eSIM mounts directly to the canister, so MVLD is natural vacuum leak detection. eSIM assembly consists of a housing, a small weight, and a large weight that serve as check valves, a diaphragm, a switch, and a cover. There's a check valve for each of the weights in the eSIM assembly with a seal attached at the end of each weighted check valve. The large weight check valve seals for pressure. The small weight check valve seals for vacuum. After the vehicle is shut down, the fuel system is sealed. As it cools, the internal pressure will drop. If the pressure drops enough to close the switch, the small leak test has passed. If the small leak test does not run, the PCM will run a medium and large leak test on startup. Using the engine vacuum, the fuel system will be drawn into a vacuum to test its integrity. So it uses the built-in vacuum in the system to see whether or not it has a leak. Kind of like what we talked about earlier. And then there's a switch test. So you can go in there and test the switch. So it shows you how to hook it up to the scope on the battery. And then at the switch itself, you're going to back probe at the eSIM signal. So right there, back probe it there, go to ground. Fuel filler cap to release any vacuum. Key off, voltage should be 5 volts. Connect the hand vacuum pump to the vacuum line from the canister. And let's see, approximately 1 inch of mercury. Switch should close, the voltage is 0 volts. Relieve the vacuum, voltage should go to 5 volts. So it's 5 volts to 0 volts in inner range. It's just a switch on and off. No real range, on or off. Fuel tank isolation valve. Located between the fuel tank and the charcoal canisters, used to manage pressure and vacuum in the fuel tank. When the fuel tank isolation valve is closed, it splits the evaporative system into 2 separate diagnosable sections during leak testing, the fresh air side and the fuel tank side. So like I said, that's that little black valve that I showed you that can close off either side of the system. During normal engine operation, it's mechanically open to relieve excess fuel tank pressure above approximately 335 kilopascals, or 4.64 psi, and excess vacuum below approximately negative 14 kilopascals, or negative 2.03 psi. When refueling when the fuel door release is pressed, this is kind of interesting. The fuel tank pressure sensor input is received. The fuel The fuel tank isolation valve, there we go, is energized, opened by the PCM, and the tank pressure is relieved at a controlled rate. When the pressure is reduced below a calibrated threshold, the fuel door is unlocked and refueling can begin. So it doesn't allow it to fuel until the pressure is equalized properly. Very interesting. And then the isolation valve is de-energized after the fuel door is closed. I thought that was kind of a unique little thing that's in there. Fuel tank pressure sensor. That's going to be voltage. All right, so voltage outputs between 0.5 and 4.5 volts, depending on tank pressure. Going to measure that for us. OBD vent valve. It's in series with the purge valve. The OBD valve needs to be turned on to allow vapors to get to the purge valve and open the eSIM switch for diagnostics. Power is from the ASD relay, and ground is controlled by the PCM. So we have that right there. We can do a voltage test on that. Should be battery positive. And then purge solenoid. A normally closed solenoid used to purge fuel vapors from the EVAP canisters. Vapors are purged back in the intake manifold to be burned again in the combustion chambers. The chassis grounded and supplied with a modulated voltage from the engine module. Pretty much like any other one. And then if we go into shop key, real quick. And we'll take a look at the EVAP system. Okay, so there's actually a TSB on this too. Small leak verification test. So if you're doing a P0456, and it's pretty much anything from 2012 to 23, Stellantis Group gas vehicles, there is a test that you can do. It says it's only on the YTech, but it's also in a Snap-on tool too. But after you're doing a P0456 code, you must run that first to verify the leak is present and run after repairing or replacing any components to verify the fix. This includes PCM software updates to correct P0456 concerns. So apparently there is a thing on that with P0456. Okay, let me pop in a scanner here. Should be in there. I don't think it's too new. Oh, it's security link. I gotta wait for that. Okay. So it should be in here. System test, perhaps? Functional tests. All right. Memory resets. Oh, this one doesn't have it. I know the RAM we're going to look at has it. So, anyways, I backed out of the vehicle. Let's get back into the Grand Wagoneer. Take a look at the system. All right, so OEM testing. There's my nice picture I found. And then component operation will tell us how the different components work. So there's where the different pieces are. Canister's way in the back. There's the diagram again. There's that, what do they call it? Ejector T, eSIM, fresh air filter, fuel tank pressure sensor, and 3 different internal tank valves, OBD vent valve. There's the purge solenoid. And then there's that vent blocker valve. All right. And then, of course, wiring diagrams. You're going to have all the usual wiring diagrams. Now, there's my fuel tank pressure sensor and the filler pipe. There's fuel pressure sensor, and the fuel line under the left front of the vehicle. So that's actual fuel pressure. That's fuel tank pressure. Difference between those two. All right, let's go to this Cadillac. So there's a new test on this Cadillac 2024 CT4 that is similar to like a bidirectional control, but it's not. So actually, first off, we have the EVAP service bay test. So that's unique to GM. So that allows you to force the monitor in the bay. It's going to be, well, I guess in a shorter drive cycle, I guess. Refer to service information to familiarize yourself with the conditions for running this test. It's going to be in 3 stages: engine idling, drive cycle, and ignition off. Verify EVAP test monitor is not already completed. Do not start the engine, set ignition on or run. Transmission to Parker neutral. Follow data parameter EVAP test state on the test screen to know when the vehicle is ready for the drive cycle and ignition off. So you need to make sure all the parameters are met, how much fuel's in there, what the temperature is. On the data display screen, start the engine and let it idle. So we want to get into the screen before we start the engine. So that's another important thing. And then it is going to give you the status right here. So the status should be, let's see, refueling, engine off, vehicle, so a lot of different statuses, and it can switch between whether it's ready or whether it needs to go to the next step, and so on and so forth. A lot of people have confusion with this, and to be fair, a lot of functional tests, because the manufacturer isn't always forthcoming as to what the parameters are that need to be met. So you just got to make sure you are sure of what those parameters are, or the test will fail. This is the new test that was added, evaporative emissions canister purge valve leak test. So it's not very fancy or anything like that. It's basically a bidirectional control that cycles it closed for 30 seconds or open for 30 seconds. So if I were to hit not venting, it's going to close it for 30 seconds. And that's just going to keep it closed. Guess it's an automated test, and you can check whether or not it leaks down. So I'm not going to wait the full 30 seconds, but that's literally the test. That's what it does. Let's see. Next vehicle is going to be this Focus. Ford Focus. And Ford does a few unique things as well under special functions. So we have gross leak tests, small leak tests. Those are automated tests. EVAP system cold soak time bypass. So this is allows you to bypass the, maybe it's a few hours before it has to run the test. It has to do a cold soak, so the vehicle has to be off. So in this case, we can bypass that. So we'll erase freeze frame data, reset OBD2 monitors, clear engine and transmission codes. Okay, key must be on with engine running before we do this. And then it's going to run it. Do not cycle the ignition key off. Time is bypassed, ready to perform the EVAP readiness monitor. So it basically forces the monitor. And then you can watch here and see whether or not the monitor has passed. Easy peasy. And then we also have got a component tests on this. So under EVAP, so component information is going to tell us about the different valves that are in there. We got the vapor blocking valve, normally open valve, electrically closed by the PCM to isolate the fuel tank from the rest of the evaporative emission system. It's kind of similar from what happened with the that Jeep. Prevents the canister from becoming saturated, causing a hydrocarbon vapor to be released in the atmosphere in the situation when the engine is off and the ignition is on during a drive cycle. EVAP vapor blocking valve will automatically open to relieve excess pressure on vacuum in the fuel tank if the pressure of vacuum reaches the maximum calibrated value. Blocking valve is located near the EVAP canister. Good to know. And then we can test the fuel tank pressure sensor, the purge solenoid, the vent solenoid. All right, one more. We're going to have this Ram 1500. So Dodge, Chrysler, Stellantis, what have you, do things a little bit different. So if we go in here and we go into miscellaneous, in this case, this one has the PCM small leak verification test. We talked about that in that TSB. Perform any service bulletins or flash updates related to evaporative fault codes before proceeding. So they know there's a bulletin on it. They know there's a flash update for it, so make sure that gets done. Procedure uses pressure over time to detect a leak. There's 5 possible test phases. You got to pass in test phase 2. The evaporative system will need to be either heating up or cooling down. There's a possible leak in the system is very stable. The second intrusive part of the test says phase 4 and 5 will run. Engine must not be running. It's going to think that it's running because it's in sim mode. So, but that is a test. Like I said, that is one that needs to be done for a PO 456. And then we're going to load this one and see what we have for EVAP tests. I was right on it. It's the eSIM again. It's going to tell us all about it. Small weight and a large weight. Fuel tank pressure sensor. 3-wire 5-volt unit. Varies output based on pressure. And then the purge solenoid. Duty cycle test, DC voltage test. All right, so that is EVAP. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week, and we'll see you on any of our other videos. Have a good week, have a good night, and take care.